So we're going to continue on with some more practice with implicit differentiation. Here I want to find the equations of all tangent lines to the curve of x plus y cubed minus y is equal to 1 at x equals 1. So I have the x value. What do I need if I'm going to write the equation of the tangent line? I need the y value. I need the slope. Let's start with the slope. I really want to focus in on finding using implicit differentiation, finding the derivative using this new tool that we have. So over here I've got x plus y cubed minus y, that's equal to 1. I want to take the derivative of this. So the derivative of x, that's going to be 1, plus derivative of y cubed, that is 3y squared. For my chain rule, times derivative of y, we'll say dy over dx, because remember y is a function of x. Minus derivative of y, that's just going to be 1 times dy over dx, so derivative of y, that's 1, times dy dx for our chain rule. Or we could just simply say minus dy over dx. We don't necessarily need the 1 there. Derivative of 1 over there on that right-hand side, though, that's just going to be 0. Okay, I have the slope of the tangent line. That's cool. Let's go ahead and solve for dy dx. So I'm going to start by moving the 1 over to the to the right-hand side. I've got 3y squared dy over dx minus dy over dx is equal to negative 1. And then I want to factor out this dy dx as I've done in the last two problems. So dy over dx, that leaves me with 3y squared minus 1 is equal to negative 1. And then just divide by 3y squared minus 1. So dy dx is equal to negative 1 divided by 3y squared minus 1. So there's my derivative, and I know that's going to end up telling me slope of the tangent line. But if I look at my derivative, the way it's defined, remember we said in the last problem, we said it might depend on both x and y. And here it actually just depends on y. Well, I don't have y. Got this x value. But I can still find the y value. I can find the y value kind of the same way I always have. I'm going to take this x value, plug it into my equation, and solve for y. So let's do that. I'm going to do that in red here, just so that we don't get mixed up. So x is 1. This is 1 plus y cubed minus y is equal to 1. Okay, we can subtract 1 from each side. This is y cubed minus y is equal to 1. Oops, is equal to 0, excuse me. Okay, well, we can factor y times y squared minus 1 is equal to 0. Take each factor, set it equal to 0, so y equals 0. Y squared minus 1 equals 0, gives me y squared equals 1, gives y equals plus or minus 1. Guys, think we got a problem here, guys. I said I was going to solve for y, and I was expecting one y value. Why the heck do I have 3 y values? How do I know which one of these to pick? How do I know which of these is on the graph of my function? So in some of these cases, okay, maybe looking at the graph will help. So luckily for us, I've graphed it. And here is x equals 1, kind of right there in the middle. We can zoom in a little bit closer there, and oh boy, guys, we've got a big problem here. So here we've got to point out 1, 1. Got a point here at 1, 0. We got a point here at 1 comma negative 1. I forgot that these aren't functions. Or rather, I pretended to forget that these aren't functions. I actually have 3 points at x equals 1. And if you'll pay very close attention to the phrasing that I use, find the equations of all tangent lines. Easy thing to overlook. But I actually have 3 y values here. I've got y equals 0, y equals 1, y equals negative 1. My slope, well, I don't know. because that depends on all of my different various y values here. So what I'm going to end up with is I'm going to end up with 3 different tangent lines, 3 different equations of 3 different tangent lines. I got to do them all. So okay, let's break this down. Let's see. So we have 3 points. Let's give ourselves a little bit of room. We're working with x is always 1, but y is either 0, 1, or -1. So we really have 3 points. We have 1, we have 1, comma 1, right? Because my x value is always 1. We said x is always 1, and then y is either 0 or plus or minus 1. So 1, comma 1. We've got 1, comma 0. We've got 1, comma -1. So I'm going to do all of these. I've got 3 different tangent lines to worry about here. But luckily for us, in each one of these we have the point. All we need is the slope, which means I need to take these y values and plug them into the derivative that we found earlier. So dy over dx, this is equal to -1 over 3 times 1 squared minus 1. This is -1 all over 3 minus 1. This is -1 over positive 2, -1/2. So this is dy dx. This is the value of my derivative at 1, comma 1. This is also my slope, -1/2. And we can go back and look. If you want to go back and double check, right here at 1, comma 1, it looks like we're going to have a negative slope. So that's good. Seems to check out. So I've got my point. I've got my slope. Let's write the equation of that tangent line. So y minus my y coordinate is 1 equals m, that's -1/2, times x minus my x coordinate is 1. Guys, we're going to have 3 tangent lines here. I trust that you can solve for y at this point. So you would take this and then just solve it for y. So y equals blah, whatever it is. Next up, I've got 1, comma 0. So okay, I'm going to do the same thing. I'm working with this derivative that I found earlier, because I still need the slope. So let's see, let's do this in red here just to break it up. dy over dx is equal to -1 over 3 times 0 squared minus 1. This is really -1 over 0 minus 1, -1 over -1, which is a positive 1. So this is the value of my derivative. This is the slope of the tangent line. So we can write the equation of the tangent line. Y minus 0 equals m is 1 times x minus my x coordinate is 1. And then you would take that and solve it for y. That one would be even easier. But we get the idea. Lastly, over here, 1, comma -1. Again, I have to go back to this derivative that I found earlier because I've got a different ordered pair. So dy over dx is equal to -1 all over 3 times y, that's -1 squared, minus 1. -1 over 3 minus 1, this is -1 over 2 once again. So that's the value of my derivative, but it's also the slope of the tangent line. So I'm going to end up with a similar tangent line, but not quite the same. Y minus my y coordinate is -1, so that's really y plus 1, equals m, that's -1/2 times x minus my x coordinate is also 1. And then again, I would take that and solve it for y, but I will leave that to you as an exercise. But hey, here we go. We've got all of our tangent lines, all of the equations of our tangent lines at x equals 1. So this just goes to show you that some of these problems can be a little bit tricky because they're not functions. We may have instances like this where we have more than one tangent line at a particular x value, in which case we need to go and find the more than one tangent lines here. If we've got 2 tangent lines, we've got to find 2 tangent lines. If we've got 3 tangent lines, we've got to find 3 tangent lines. So just be on the lookout for some kind of wonky behavior where these functions, well, I should say these relations don't act like functions because they're not functions.